NEC 400.84 prohibits the use of flexible cords where attached to building surfaces, so you cannot staple or otherwise attach so cord to the exterior of a building. However, you may run the cord loosely along the surface, provided it is not exposed to damage. Since so cord cannot be attached to the building exterior, you should consider using a different type of cable that is suitable for outdoor use and can be attached to the building. Some options include, firstly, non-metallic underground feeder cable, which is rated for direct burial and can be used outdoors and can be stapled to building surfaces. Secondly, non-metallic sheets cable, also known as Romex, is commonly used in residential construction and can be stapled to building surfaces, but it is not rated for outdoor use. However, you can run it through a conduit that is installed outdoors. Thirdly, service entrance cable is designed for use as a service entrance conductor from the utility pole to the building and can be attached to building surfaces. In your specific application, it is recommended to use UF cable to run from the power converter to the junction box. UF cable is rated for outdoor use and can be attached to building surfaces. In addition to the NEC requirements, you should also consider the following. Firstly, weatherproofing the cable, and any connections should be weatherproofed to prevent damage from rain, snow, or other elements. Secondly, UV resistance. The cable should be UV resistant to prevent degradation from sunlight. Thirdly, mechanical protection. The cable should be protected from physical damage, such as being stepped on or cut. By following these guidelines, you can ensure a safe and code-compliant electrical installation for your powered awning. Let's delve into the technical aspects of selecting the appropriate wiring method for your powered awning project, considering the requirements of the National Electrical Code, or NEC, and practical installation considerations. The primary concern is adhering to NEC 400.84, which restricts the use of flexible cords when attached to building surfaces. This means you cannot secure so cord directly to the exterior of the house using staples, cable ties, or any other fastening method. The code aims to prevent mechanical damage to the flexible cord, which could compromise its installation and create a safety hazard. If the so cord is not attached to the building surface, it must still be protected from physical damage as per NEC 400.14. This means ensuring the cord is not exposed to sharp edges, abrasion, or other conditions that could damage the insulation. For example, running the cord loosely over a rough brick surface would not be compliant. Given these restrictions, let's examine suitable alternatives to sew cord that meet both the functional and safety requirements of your application. Firstly, consider non-metallic underground feeder cable, or UF cable. UF cable is specifically designed for direct burial and outdoor use, making it an excellent choice for this application. Its construction includes individual insulated conductors encased in a solid, water-resistant thermoplastic jacket. This jacket provides superior protection against moisture, sunlight, and physical damage compared to sew cord. UF cable is available in various sizes to accommodate different amperage requirements of your 12-volt direct current motor. To determine the appropriate size, calculate the full load current of the motor using the formula power equals voltage times current. Rearranging the formula, current equals power divided by voltage. Once you know the current, refer to NEC table 310.15. V16, which provides the ampacity of conductors based on their insulation type and ambient temperature. Be sure to select a UF cable with an ampacity that meets or exceeds the motor's full load current, taking into account any applicable derating factors for ambient temperature or multiple conductors in a raceway. UF cable can be securely fastened to the exterior of the house using appropriate cable staples or clamps designed for outdoor use. Ensure that the staples or clamps are made of corrosion-resistant materials such as stainless steel or plastic to prevent deterioration over time. Space the supports according to NEC 334.30, which generally requires supports at intervals not exceeding 4½ feet and within 12 inches of boxes, cabinets, and fittings. When transitioning from the UF cable to the motor on the awning, use a weatherproof junction box to protect the connection from the elements. The junction box should be listed for outdoor use and have an MA3R or higher rating, indicating its ability to withstand rain, snow, and ice. Inside the junction box, Use weatherproof wire connectors, such as gel-filled connectors or heat shrink connectors, to ensure a watertight seal. These connectors prevent moisture from entering the connection and causing corrosion or electrical faults. Another alternative, if the SO cord cannot be used, is to use non-metallic sheath cable or NM cable, also known as Romex. However, NM cable is primarily intended for indoor use and is not rated for direct exposure to the elements. To use NM cable outdoors, you must protect it within a conduit system. Conduit provides a physical barrier against moisture, sunlight, and physical damage. Suitable conduit options include, firstly, rigid metal conduit, or RMC, which is the most robust option and provides excellent protection against physical damage. Secondly, intermediate metal conduit, or IMC, which is lighter than RMC but still offers good protection. Thirdly, electrical metallic tubing, or IMT, which is a lightweight and cost-effective option for protected locations. Fourthly, rigid polyvinyl chloride conduit, or PVC, which is a non-metallic option that is resistant to corrosion. When selecting conduit, consider the environmental conditions and the level of protection required. For example, in areas with high levels of corrosion, PVC conduit may be the best choice. Size the conduit according to NEC Chapter 9, Table 1, which provides the maximum number of conductors permitted in different sizes of conduit. Ensure that the conduit is properly supported using appropriate hangers and straps, spaced according to NEC 352.30 for PVC conduit and NEC 344.30 for RMC, IMC, and EMT conduit. Seal the ends of the conduit with appropriate fittings, such as conduit bodies and sealing lock nuts, to prevent moisture from entering the system. When transitioning from the conduit to the motor on the awning, use a weatherproof junction box as described previously. A third option is service entrance cable, or SE cable, is typically used for the main electrical service entrance to a building. While it is rated for outdoor use and can be attached to building surfaces, it may not be the most practical choice for this application due to its larger size and stiffness compared to UF cable. SE cable is designed to carry higher amperage loads and may be overkill for a 12 volts direct current motor. If you choose to use SE cable, ensure that it is properly supported and terminated according to NEC Article 338. Now let's consider the power converter that will supply 12 volts direct current to the motor. The power converter should be installed indoors in a dry location. Ensure that the power converter is properly sized to provide sufficient current to the motor. The power converter should also be protected by an overcurrent device such as a fuse or circuit breaker, sized according to NEC 430.52, which governs the protection of motor circuits. The overcurrent device should protect the power converter and the wiring from overload and short circuit conditions. When running the wiring from the power converter to the junction box and the exterior of the house, follow the same guidelines as described previously for the wiring from the junction box to the motor. Use UF cable or NM cable in conduit and ensure that all connections are weatherproof. Pay particular attention to grounding and bonding requirements. Grounding ensures that the electrical system is properly connected to earth, providing a path for fault current to flow back to the source and trip the overcurrent device. Bonding connects all metal parts of the electrical system together, creating an electrically continuous path that minimizes the risk of shock. Grounding and bonding should be performed according to NEC Articles 250 and 680. In summary, to ensure safe and compliant electrical installation for your powered awning, follow these key steps. Firstly, select a wiring method that is suitable for outdoor use and can be attached to building surfaces, such as UF cable or NM cable in conduit. Secondly, size the wiring and overcurrent protection according to the motor's full load current and NEC requirements. Thirdly, use weatherproof junction boxes and connectors to protect all connections from moisture. Fourthly, properly ground and bond the electrical system according to NEC Articles 250 and 680. Fifthly, ensure that all materials and equipment are listed and labeled for their intended use. By adhering to these guidelines, you can create a reliable and safe electrical system for your powered awning that meets the requirements of the NEC and protects against electrical hazards. Consider the importance of ultraviolet resistance. Sunlight contains ultraviolet, or UV, radiation that can degrade many types of cable insulation over time. This degradation can lead to cracking, brittleness, and eventual failure of the insulation, exposing the conductors and creating a safety hazard. To prevent UV degradation, select cables that are specifically rated for UV resistance. These cables are typically made with insulation materials that contain UV inhibitors, which protect the insulation from the harmful effects of sunlight. Look for cables that are marked with the UL or other recognized testing laboratory listing indicating their UV resistance. When installing cables outdoors, try to minimize their exposure to direct sunlight as much as possible. Route the cables along shaded areas or under eaves where they will be protected from the sun's rays. If you must run cables in direct sunlight, consider using a UV-resistant conduit or cable tray to provide additional protection. Remember that even UV-resistant cables will eventually degrade over time, so it is important to periodically inspect them for signs of damage and replace them as needed. Weatherproofing is another critical consideration for outdoor electrical installations. Rain, snow, ice, and humidity can all penetrate electrical connections and equipment, leading to corrosion, short circuits, and other problems. To ensure weatherproofing, use only equipment and materials that are specifically rated for outdoor use. This includes firstly, weatherproof junction boxes, which are designed to prevent water from entering and damaging the electrical connections inside. Weatherproof junction boxes typically have gaskets and seals that create a watertight barrier. Secondly, weatherproof connectors, which are used to connect wires and cables to junction boxes and other equipment. Weatherproof connectors have O-rings and other sealing features that prevent water from entering the connection. Thirdly, weatherproof conduit fittings, which are used to connect sections of conduit together into junction boxes and other equipment. Weatherproof conduit fittings have gaskets and seals that prevent water from entering the conduit system. When installing weatherproof equipment, make sure that all gaskets and seals are properly installed and tightened. Also, be sure to use the correct type of sealant or caulk to seal any gaps or openings around the equipment. In areas with heavy rainfall or snowfall, consider using additional weatherproofing measures, such as installing a rain shield or drip lute to prevent water from running directly onto the electrical equipment. Mechanical protection is also essential to prevent physical damage to electrical cables and equipment. Cables that are exposed to physical damage can be cut, crushed, or braided, leading to short circuits, ground faults, and other hazards. To provide mechanical protection, use conduit or other protective raceways to enclose the cables. Conduit provides a physical barrier against impacts, abrasion, and other forms of damage. When installing conduit, make sure that it is properly supported and secured to prevent it from being dislodged or damaged. In areas where cables are exposed to heavy traffic or equipment, consider using rigid metal conduit or other heavy-duty raceways. You can also use cable guards or barriers to protect cables from physical damage. These guards or barriers are typically made of metal or plastic and are designed to deflect impacts and prevent cables from being crushed. When running cables through walls or floors, use bushings or grommets to protect them from abrasion. Bushings and grommets are typically made of rubber or plastic and are designed to fit snugly around the cable, preventing it from rubbing against the edges of the hull. In addition to physical protection, it is also important to protect cables from pests. Rodents and insects can chew on cables, damaging the insulation and creating a fire hazard. To prevent pest damage, use rodent-resistant or insect-resistant cables. These cables are typically made with insulation materials that are treated with pesticides or repellents. You can also use pest-resistant conduit or cable trays to provide additional protection. Regularly inspect cables for signs of pest damage and take steps to eliminate any pests that are found. Finally, consider the importance of proper installation techniques. Even the best materials and equipment will not provide adequate protection if they are not installed correctly. Follow the manufacturer's instructions carefully when installing electrical equipment. Make sure that all connections are tight and secure, and that all wires are properly insulated. Use the correct tools and techniques for each task. If you are not comfortable performing electrical work, hire a qualified electrician to do the job. A qualified electrician has the training and experience to install electrical equipment safely and correctly. By following these guidelines, you can ensure that your outdoor electrical installations are safe, reliable, and code compliant. Remember that electrical work can be dangerous, so always take precautions to protect yourself and others.